Now we'll study integration by trigonometric substitution. We have studied before algebraic substitution, which, for example, we had, if I had an integral like this, how would I solve this integral? Whenever I find a root and a root with a linear inside it, I am sure that whenever I'm sure that if I make an algebraic substitution for this, it will be simplified. Okay, so this will be y squared x minus 1, x will be y squared plus 1, dx is equal to 2y dy. Then I substitute in this integral, so the integral will be simplified with no roots. Okay, now this cannot be applied in all integrals. For example, if I had this integral, if I make a substitution for the root, it won't be solved. If I say that y is equal to root x squared plus 1 and y squared is equal to x squared plus 1, whenever I try to eliminate the root by substitution, I find it return again. So in this case, I will have here that x is equal to root y squared minus 1, and the x will be dy over some new root. So when I make the substitution, I will get another root. Okay, if I make a substitution like this, when do I know that the substitution of the root will be simplify the integral? If what is inside the integral is linear. In this case, I'm sure that the integral will be simplified. But if what is inside the integral is non-linear, I'm not sure. Sometimes it is simplified, sometimes not. Okay? Now we will learn how to treat integrals with quadratic formulas inside some root or in the denominator. For example, this integral, x squared plus 1, or let it be 1 minus x squared. This integral cannot be solved by any of the methods we have learned. Substitution, algebraic substitution, if I take y equals root 1 minus x squared, if I try to eliminate the root, it will not be eliminated. I will find another root that will come out from the substitution. So it is not simplified by a substitution, an ordinary substitution. But this can be solved by something called trigonometric substitution. What is trigonometric substitution? Trigonometric substitution makes use of the formulas of trigonometric functions, which is 1 minus sine squared theta is equal to cosine squared theta. These are two terms are turned into one term. Also, we have 1 plus tan squared theta is equal to sec squared theta. These are two terms are turned into one term. Also, we have that sec squared minus 1 is equal to tan squared theta, which is another form for this formula. But here we have two terms that will turn into one term. Okay? Now, what is the idea here? The idea here is that I put x to be sine x, so that 1 minus sine squared will be cosine squared, all under the root will be one term, it will be simplified. Okay, so we have here 1 minus x squared. I will take x to be sine theta. Then to make the substitution, I put it dx is equal to cosine theta d theta. So this integral will be integration of root 1 minus sine squared theta. I put the x as sine theta. Okay, now this is 1 minus sine. I removed the x and substituted by sine theta. Now I have to remove the dx and substitute by cosine theta d theta. Now I'm expecting to have some simplification here. 1 minus sine squared is cosine squared. and under the root will be cosine. So this is cosine theta multiplied by cosine theta d theta. Cosine integration of cosine squared theta d theta. So now this integral has transformed to this form. Cosine squared theta. Can I solve this integral? Yes. By a reduction formula. This is half integration of 1 plus cosine double the angle. Okay. Now this, the result of the integral will be half x plus sine 2 theta over 2 all plus c. Okay. Now we have solved the integral. This is theta. This is theta, not x, because we are integrating with respect to theta. Okay. Now this is the result of the integral. We just need one remaining step, which is to return the result to be in terms of x, which is the original variable of the integral. We have to make it, instead of theta, we have to make it as x. How would I make it? How should we make it to be in terms of x? This is by this substitution. What does it mean to have x is equal to sine theta? We just make it by a triangle. X is equal to sine theta. Sine theta, if I assume this is the angle theta, it will be x over 1. X over 1, which will be this over 1. Do you know this? How to make it in a triangle? Now I complete the triangle. It will be 1 minus x squared. Okay, now this is the triangle of theta. Any trigonometric function that I need for theta, I just substitute it by the triangle. Okay, for example, now this is sine 2 theta. Sine 2 theta, but this is the triangle of theta. I need to put it in terms of theta, which is 2 sine theta cosine theta all over 2, and the 2 is eliminated. So this term is sine theta multiplied by cosine theta. What is sine theta? Sine theta is from the triangle is x power over 1. What is cosine theta from the triangle? It is root 1 minus x squared all over 1. Okay, now it remains to express theta in terms of x. If I had a theta, just a theta alone without a trigonometric function, not inside a sine or cosine or tan or any of these, I just say that theta is sine inverse of x. Okay, now this theta is sine inverse x. Okay, now we have learned how to make a trigonometric substitution and how to resubstitute it in terms of x again. Okay, now we will make some systematic steps. Whenever I find root or expression for an expression a squared minus x squared, or a squared plus x squared, or x squared minus a squared, whenever it is inside a root or in a denominator or any of these, and I want to eliminate them by trigonometric substitution, we use here a substitution x is equal to a sine theta. Why? Because when I make the substitution, a squared minus a squared sine squared theta, I take a squared common factor. Then these two terms, 1 minus sine squared, is transformed to, it will be cosine squared. Instead of two terms, it is now only one term. So if it is inside a root, it will be easier or simpler. Okay, now also this a squared plus x squared, we use the substitution a tan theta. Why? Because if we substitute here a squared plus a squared tan squared theta, we have here a squared plus tan squared theta. 1 plus tan squared is known as sec squared, which instead of two terms we have here only one term. If this was inside a square root, so this will be inside the square root, it will be a sec theta only. It will be simplified. Okay? For x squared minus a squared, we use the substitution x equals a sec theta. Why? Because if we substitute here a squared sec squared theta, I just substituted x with a sec theta minus a squared. I take a squared common factor, will remain sec squared minus 1. What is sec squared minus 1? It is tan squared theta. If it was inside a root, it will be simplified. Okay? Now these are the three rules that we will apply. These are the three rules that we will use to make that trigonometric substitution. Okay? Now we have some steps for trigonometric substitution. First is to decide which of these that we will use to make the substitution. Okay? The second step is to apply the substitution and make the simplifications. The third step is to, after finding the result of the integral, is to resubstitute it by x. Okay? So we have 3 steps and 3 skills that we have to learn how to apply them. Okay? Let's see another example. If I have this integral, root x squared minus 25 over x dx. Now, first, I have seen here that I have a square root, but inside it, it is not linear, it is quadratic. Whenever what is inside the root is quadratic, we think about trigonometric substitution, not ordinary substitution, or not algebraic substitution. Okay, so I don't see here that y equals root x squared minus 25. No. What is most suitable here? Trigonometric substitution. So what of these should I use to make it simpler? The last one, which is sec theta, which is x equals 5, which is the root of this, 5 sec theta. dx is equal to 5 sec theta tan theta d theta. Okay, now we make the substitution. Here we have decided which substitution we'll use. Now we have to apply the substitution. Integration of. Now we'll apply this first in detail, that we will learn how to make it quickly. This is the root that I made the substitution for. This one, root 25 sec squared theta minus 25 over x, which is 5 sec theta, dx, which is 5 sec theta tan theta d theta. Okay, now let's focus on this. First, we will have a squared as a common factor. Okay, a squared as a common factor under the root, so we'll just take the a squared, this will take it out of the root with its power, so it will be 5. Okay, what will remain? Will remain root x sec squared minus 1. What is sec squared minus 1? It is tan squared. Okay, now sec squared under the root, tan squared under the root will be tan theta. This one will be eliminated by this, 5 will be eliminated with 5. Now what will remain is 5 tan squared theta d theta. How can we solve tan squared d theta?
Reduction.
No.
Sec squared.
Sec squared, yes, it is sec squared minus 1, which is the 5 tan theta minus theta plus c. Now what will remain?
Substitution.
Yes, we have to resubstitute it to be in terms of x. How? We just express this as x over 5 is sec theta. And we make the triangle of theta. Now we have sec is equal to x over 5. What is sec? It is
Inverse
the
of
reciprocal of
cosine.
cosine. Yes, it will be x over 5, like this. I complete the triangle. This will be square root of the hypotenuse, which will be x squared minus 25. So I have here the complete triangle for theta. Any trigonometric function that you need, I will get it from the triangle. Now I need tan theta. I need here tan theta. What is tan theta from the triangle?
Yes.
It is the root over 5. Okay, this will be x squared minus 25 over 5. Minus theta. What is theta? We just express it from here. It is sec inverse x over 5. This from this one. Theta is sec inverse x over 5.
Yeah.
Okay? We have learned how to apply the trigonometric substitution. Okay? Now we have integration of dx over x power 4 root 4 minus x squared. I've noticed here a quadratic form inside the root. So this will be a substitution of trigonometric substitution, not algebraic substitution, because we have a quadratic, not linear. Yes. So now we have, I say x is equal to, what is the most suitable substitution here? Sine. But we have here 2 sine theta, because we have here 4.
Yeah.
So now dx is equal to 2 sine 2 cosine theta d theta. Now I apply 2 cosine theta d theta على over x power 4, which is 2 power 4 sine power 4 theta. Now I apply the root, which is, I take 4 out of the root, which will be 4 over the root. Okay? Now I apply the sine, which will be 1 minus sine squared, which is cosine squared. Under the root will be cosine squared like this. I make it in one step. Instead of first substituting, then taking the common factor and taking it out, I just make it, I take the number here, I take it out with its power. I take it out with its power, which is root 4. Okay, then I apply this. I just take it as it is 1 minus sine squared. It will be cosine squared under the root. Okay, this is cosine, it will be eliminated with this, and this will be 2. So we have here 1 over 2 power 5 integration of d theta over sine power 4 theta. How can we solve this integral?
1, 2 is gone. Also, this 2 and this will
this
power 4.
yes, this one is so it will be 2 power 4. Yes. How can we integrate 1 over sine power 4 theta?
Sec.
Yes, we express it as sec. Whenever we have a sine or cosine in the denominator, we express it as sec or cosec. So this will be 1 over 2 over 4, which is cosec power 4 theta d theta. We have just learned how to deal with these expressions. This is cosec cotan. Cotan is not here, so it is for the power 1. Now we have here an even power for cosec. We have learned whenever we have an even power for cosec or sec, we take sec squared or cosec squared after the d. So this will be 2 over 4 cosec squared theta d cotan theta in a negative. Now we just need to express this in terms of cotan theta, which will be 1 plus cotan squared theta d cotan theta, which is if I take this as y, this will be integration of 1 plus y squared dy, which will be 1 plus y over 3 over 3 power 3 over 3, and this will be y. Okay, now I return y to theta. I return y to theta, which is cotan theta. This will be cotan theta plus cotan cubed theta over 3. This is the result of the integral with some constant here. Okay, there is still one step, remaining step, which is to replace it to x. How would we do this? Yes, we'll take x over 2 is sine x, sine theta. We make the triangle of theta x over 2. This will be 4 minus x squared. So we have the triangle of theta, and we need cotan theta.
Inverse.
What is cotan theta from this? It will be root of x minus x squared over x. So this will be root
4 minus x squared.
Root 4 minus x squared over x plus root 4 minus x squared over x, all power cubed, all over 3. And this is all multiplied by 1 to minus power 4. Okay? So we have learned how to deal with expressions with a root, and inside it we have some trigonometric, some quadratic form. Okay? We may have an integral like this, with some inverse trigonometric function inside the integral. We learned before how to make integral like this. How would we solve this integral?
By part.
By parts, yes. This is solved by parts. But some integrals like this, actually you can solve it by parts also, but it's better to be solved by eliminating the inverse function by substitution. How? We say here that theta is equal to tan inverse x. Theta is equal to tan inverse x, which means that x is equal to tan theta. So dx is equal to sec squared theta d theta. Okay? Now we make the substitution. X is tan theta. Tan inverse x is theta. I just put it here. Okay? Divided by 1 plus x squared. 1 plus tan squared theta. What is 1 plus tan squared theta?
Sec.
It is sec squared theta. And we remove the dx with sec squared theta d theta. Yes, this will be cancelled with this. So what will remain is integration of theta tan theta d theta. Now it is very obvious that this integral is solved by parts. It's very obvious it's solved by parts. We can make it as theta tan theta. This is 1, this is 0. This integration of tan theta is ln sec theta. Another integral. No, it will not be solved by this method. We just make it by sorry, this is tan. Oh, sorry, this is x squared. So this will be
theta square.
theta.
Square.
No, it will be tan squared.
Square.
Tan squared multiplied by theta. This is theta.
Yeah.
Okay, so this is tan squared theta.
Yeah.
Yes, yes.
Okay,
Yes.
how would we solve this? This is algebraic and trigonometric. What is the priority to be taken after the D? For the trigonometric. So we are thinking about how to integrate tan squared theta. How do you integrate tan squared?
Reduction.
No, not
It will be
reduction.
sec square.
Sec squared minus 1.
Yes.
So we just make these steps, we make it here. So theta sec squared theta minus 1 d theta, which will be two terms,
Theta.
x sec squared theta d theta minus integration of theta d theta. Okay, this integral will be theta, this will be theta d tan theta, and the other integral is theta squared plus c. Okay, this integral we will solve it ordinarily by parts. It will be no problem here. Okay, then the remaining step will be to return it to x. This is by theta x over 1, which will be x over 1, and this will be 1 plus x squared. Okay, so I've learned also how to, if I have some inverse symmetric function inside the integral, we eliminate it, or we make a substitution for it by theta. Okay. Okay, now what if we had an integral like this? Make it x power 3 over 2. If we have an integral like this, here we have a root and a quadratic form like this. Now, if it was integration of x squared plus 5, 3 over 2, we would have used the substitution root 5 tan theta. Do you agree with me or not? X squared plus 5 all over 3 over 2, all power 3 over 2, which is where we have here a root. And this is x squared plus a squared. So we use here tan theta. This is the most suitable substitution. We learned this in the substitutions before. Here, a plus x squared, we use this substitution. Okay? But now we have another term here, which is 2x. Do you remember we have learned how to deal with these expressions and make it as a form as something squared plus or minus something? Completing square, yes. So how we deal with this? We just make complete square. So we make it x minus 1 all squared minus 1 plus 5. So this will be x minus 1 all squared plus 4 whole power 3 over 2. Now what is the substitution here? We will take this x minus 1 as 2 tan theta. Why? Now here this is the expression that is taking the place of x before. Now it is just like this.
Oh, yes.
It's just like this, but we have another linear form instead of x. So this is x minus 1 equals 2 tan theta. Okay, so dx is equal to 2 sec squared theta d theta. Now the integral will be integration. I just told you that the first step is to take the 4 with its power, which is 4 over power 3 over 2. Okay, now we substitute for tan. Tan squared plus 1 is sec squared theta, all power 3 over 2. Okay, this is instead of substituting, then taking common factor, then taking it out, we just make it by 2 steps. I take the number with its power out the integral, the first step. The second step is take the function of the substitution and I apply the rule immediately. I take it just 1, or I just apply it directly. 1 plus tan squared is sec squared. Okay, now dx is 2 sec squared theta d theta. Now this is 4 over 3. This will be sec over 3 sec power 3 theta, and this is sec power 5 power 2 theta d theta. So it will be integration of sec power 5 theta d theta. This is an odd power for sec, which will be solved by taking it to its original by parts and original. This is the we studied in the trigonometric function. We studied 3 cases. One is looking for an odd power for the tan. One is on even power for the sec. If it is not, this is the case which was here. The third case, which is neither this or this, we solved it by parts and making it to the original integral. Okay, this integral is not required. We just make it for the 3rd degree if it is sec squared or tan 3 sec cubed. So we are not obliged to make this integral. Or we can make the integral as x minus 1 divided by x minus 1. So it will be here 2 tan theta Okay, I'm just showing you the idea of how to treat this this integral by completing square. Okay. Hyperbolic substitutions will be cancelled. Hyperbolic, if we have said before, hyperbolic substitution is not required. Okay, this cancelled. Now we have stopped here we have studied trigonometric integrals and trigonometric substitution today. Okay, this is the integration part. Still remaining that we will study one lecture in a series lecture. Okay, we will just take a break, then we'll take our lecture. Okay, 10-minute break, then we'll take our lecture.